Hello to all the members of Everest Analytics 20. I'll give the word to Carlos of the first project, which is a combined
Thanks. I suppose it's better if I share screen for the presentation.
Yes.
Right. Let's do this. Okay. Let's see. There you go. So, good evening. My name is Carlos Andrade. I'm with DeltaQ.io. What we provide at DeltaQ is a service in which we try to improve the thermal comfort and the well-being of the inhabitants or the occupants of a building, on a commercial building. At the moment, we also try to expand to retail and residential. Our logo, predictive control, better buildings. One of the main problems that we see with buildings these days is that you have a ridiculous amount of data. That's good news, and now that everything seems to be or wants to be data-driven. You have these small computers in each building, a building management system that has easily up to 10,000 data points from any points. Could be temperature sensors, alarms, other sort of system measurements. The problem, though, is that we're not exploiting this data very well. One classic problem that we have in buildings is bad comfort. You may have noticed, well, not last week because we are all at home with lockdown, but buildings tend to be reactive traditional control systems in which we will start only the heating or the cooling of the building a few hours before people come to the building. Sometimes this works, sometimes this doesn't work. So it's more of a reactive approach that generally doesn't take into account weather predictions, knowing the knowledge that there's going to be a cold wave, for example. Another issue that we see in buildings is the performance gap, in which we know that buildings are not going to perform as designed. Design gives you a certification and energy rating, but in practice, buildings just end up consuming much more energy. There are inefficiencies here and there. People just put settings and forget to change them, etc. And this it's due to the nature of the work that's carried out by operations and maintenance crews, that is rather inefficient. They have to do these manual setting changes every weekend, every Monday morning, or every time that you have a special event. You have to do these changes manually, change a set point of a handling unit, of starting the boiler, for example. All of this is just inefficient. What we want to do this is through automation, through a software as a service system, that where we optimize building control systems in real time. This takes us 3 steps. First, we connect the building control, systems, mostly the computer, the building management system, through our device, through our gateway, gather all possible data, from which we build. From this data, we build a machine learning model. We capture the physics of the building, the energy systems as well, and the occupancy. We come up with a digital twin of the building. And using this digital twin plus optimization algorithms, we come up with a predictive control that anticipates future conditions of weather, performance evaluation, sanity checks, and in the future, we're going to introduce what's demand response events and others. We aim to improve comfort in buildings, try to make the people more comfortable, improve, enhance productivity, reduce energy emissions, and therefore reduce energy consumption, emissions, and, well, most importantly, improve savings, reduce bills for customers, and furthermore, reduce the operational cost of interventions, the manual interventions that was requiring. That's it from our side. At the moment, I think I handed it to Matthias at ML6.
All right. Thank you. I'll also start sharing my screen now. Oops. Yeah, I hope my screen is visible.
Yes, it is.
All right, awesome. Yeah, well, so small introduction. I won't bore you with the numbers. Basically, the obligatory, of course, introduction. So yeah, at ML6, we're yeah, consultants really leveraging ML to help companies accelerate intelligence. So I have some numbers here, but basically what it means is that we have other companies, typically bigger companies, to find ways to really leverage ML. And this is yeah, on all different areas. So all our projects always include ML. However, we cover computer vision, NLP, structured data, time series. So all the types of ML. So that's basically what we do as a company. So how we do that is by not really focusing on one specific industry, but really looking for gains that we find in one industry to leverage this in another. So you can also see that we have really a broad view of typical organizations within each industry that we all try to help in a typical same way to really make sure that they are at the brink of what's possible, to really help their R&D teams or to really help their organization as well to leverage the latest state of the art. And by focusing, of course, on our great colleagues. So we have around 80 colleagues over 5 different locations. With current situation, it's a bit easier to collaborate over these distances. Basically, this is a big one to really have a lot of these great colleagues. And we use typically Google Cloud Platform and their frameworks as a way to get there. So that's a small intro on that end. Today, it's just 2 slides. Basically, as Carlos already shared, they do have a lot of systems set up. So it's a tricky project in the sense that it's not just doing whatever, it's really to improve what they already have. So, and in that respect, it makes sense, of course, to make sure that we focus on the right things. So what we'll work on during this semester is just on the digital twin part. So really the one step ahead predictions that they currently have, the way that they currently do it. The goal is to see how we can improve that. So that's the idea, that we basically just have this black box that we can also share with Carlos and his team in a way that it really works better than the current system that they have. And that we can also leverage the learnings, of course, of what they have right now. So the approach to do this is to start with understanding success. It's really a critical one to make sure that we work towards the same goal. And in this sense, basically, Carlos already shared some data sets, and they will also calculate their current root mean squared error that they get on this data set as their current predictions, so that we can really start just optimizing from that. So basically, we have 2 streams. We have one focusing just on the model, so that we basically look at different algorithms. We have room for testing multiple algorithms and multiple ways to improve this. Basically, in the first iteration, we just start with the raw data that we get, and then first share this, and then based on feedback, that we can have multiple iterations on this to keep on improving it over time. But the goal here is really to have, even after 1 week already, something that we can share that they can actually already use, and we can keep on improving this over time. And in the same time, also designing a roadmap for integration, because this model needs to run at DeltaQ, of course. So we first need to decide how we'll want to integrate this. So it's something, again, to sync with Carlos' team, but basically we need to work as a clear way to run inferences, and also for them to be able to retrain it, because that's basically the goal, is that we have this model that we can share with them and that they can also keep on using over time. So that's really quickly what this project is about. It's not by doing the whole system. It's really focusing on this specific part that we can do together, and that is what we'll focus on during this semester.
Okay, perfect. Thank you very much, Matthias. I wish the team members, Boris, Divan, Tommy, Michiel, and Louise, a lot of good luck, and hopefully you get a lot of new experience with ML6 and DeltaQ. So now I will give the word to Louis-Philippe en Tessa de Kramer.
Hi everyone, I will first share my screen. Okay. Normally you should be able to see it. Do you see my screen right?
Yes.
Okay, so I'm Tessa, I'm actually the president of Everest Analytics, and I will assist the group that will tackle the problem of kom op tegen kanker.
Tessa, I will interrupt. I think you are presenting with slide modes.
Yes, like this. Is this better?
Yeah, much better.
Okay. Okay, so I will assist the group from Kom op tegen kanker again with Crunch. So the goal will actually be to predict the future donation behavior and analyzing the effectiveness of external communication using NLP. But before we go in deeper to the actual goal of the project, I will quickly give some explanation about Kom op tegen kanker. I will do this via a video from Kom op tegen kanker itself, but it is in Dutch, so I hope there's not a big problem about that. But I will quickly recap in English afterwards.
Dankjewel. Dankzij jouw steun neemt Kom op tegen kanker al ruim 30 jaar initiatieven om kanker te vermijden, te bestrijden en te verzachten. Want onze droom is een wereld zonder kanker. Daarom investeren we in informatie en preventie, beleidsbeïnvloeding, onderzoek en zorg. Zo zette Kom op tegen kanker in 2019 belangrijke stappen vooruit in de strijd tegen tabak. Roken in de auto is voortaan verboden als kinderen meerijden. Omdat we generatie rookvrij in het Vlaamse regeerakkoord wisten te loodsen, zal de regering er mee voor zorgen dat elk kind dat vanaf 2019 geboren wordt, rookvrij kan opgroeien en niet begint te roken. Insta Verliefd, de allereerste fictiereeks op Instagram in Europa, maakt jongeren weerbaarder om niet te beginnen roken. Bovendien worden jongeren beter beschermd tegen een tabaksverslaving, nu sigarettenpakjes er neutraal moeten uitzien en je pas tabak kunt kopen vanaf je 18e. Kom op tegen kanker investeerde ook €349.970 in wetenschappelijk onderzoek voor een betere kankerpreventie. 48 biomedische en 3 psychosociale onderzoeksprojecten kregen samen bijna €15,5 miljoen om meer patiënten te doen overleven en hun levenskwaliteit te verbeteren. Pancreas- en slokdarmkankerchirurgie mogen alleen nog gebeuren in ziekenhuizen die minstens 20 complexe slokdarm- en pancreasoperaties per jaar doen. Hoe meer ervaring een ziekenhuis immers heeft, hoe meer kans een patiënt heeft op een succesvolle behandeling. 95 kankerpatiëntjes beleefden de week van hun leven op het jaarlijkse vakantiekamp. Voor jongeren met kanker stonden 34 buddies dag na dag klaar. 1268 kankerpatiënten met een laag inkomen kregen samen €1.373.520 financiële steun uit het kankerfonds. De kankerlijn beantwoordde oproepen van 2628 patiënten en hun naasten. Zorgvrijwilligers voerden samen bijna 34.000 gesprekken in bijna alle ziekenhuizen in Vlaanderen. Asbestslachtoffers worden beter omkaderd dankzij ons jarenlange beleidswerk. De steun voor patiënten met longvlieskanker werd verhoogd en wie long- of strottenhoofdkanker opliep door asbest, krijgt voortaan een vergoeding van het Asbestfonds. Tijdens de dag tegen kanker werden 250.000 lintjes opgespeld. 2345 patiënten kregen een steunend berichtje. €4.018.839 investeerden we in de kinderoncologie, lotgenotengroepen, palliatieve zorg, zorgorganisaties en vernieuwende initiatieven in de zorg. Denk aan inloop- en zorghuizen. En last but not least, dankzij Kom op tegen kanker mogen verzekeraars vanaf 1 februari 2020 geen rekening meer houden met een kankerdiagnose als het einde van de behandeling meer dan 10 jaar geleden is. Zo gaan we voor een betere levenskwaliteit. Het kon allemaal en nog veel meer dankzij jullie. Dankzij 339 comité's die tijdens het plantjesweekend 339.310 azalea's verkochten. Ongeveer 70.000 kinderen die de pet op tegen kanker droegen. 1140 teams die 1000 kilometer fietsten tijdens het hemelvaartweekend. 581 teams die de 100 kilometer run liepen. De duizenden vrijwilligers die over heel Vlaanderen allerlei acties organiseerden. De tienduizenden donateurs en de vele gulle erflaters die schonken aan Kom op tegen kanker. Dank jullie wel. 30 jaar Kom op tegen kanker, dat zou nooit lukken zonder jullie. Daarom bedankten we iedereen in het voorjaar een heel weekend lang. Kom op tegen kanker zet de strijd verder, tot de dag waarop we geen geliefde meer verliezen aan kanker.
Okay, so this was a good explanation about what they do, and you can actually see it in 5 goals. They try to support the patients with cancer as well as their loved ones, and as the people that support them, the caregivers that support them, or the volunteers that support them. Then they advocate for a better future, for better policies, so they work together with the politics and so on. They finance several research groups, as well as they help finance some treatments for people who cannot afford it themselves. And then prevention and fundraising is also very important. And this is actually where we will step in the fundraising part of Kom op tegen kanker, because we want to help them for getting efficient fundraising and to get even more donations than they get right now. So as you saw in the video, there are several yearly events, the 100 kilometer running event, 1000 kilometer biking event, or they sell plants. And this is actually what we will see in our data as well. So we will use data from donors that are not linked to one of these events, but we want to see the impact of the events. Is the period around the running event, for example, does this increase donations, yes or no? These are things that we will see from the data. So right now I will give the word to Louis-Philippe from Crunch, who will further explain the project.
Right, so still at the start of the project, so I'll explain how we plan on approaching the project. I'll just share my screen quickly. Normally, you should now see my presentation. All right.
Yes.
Yes, so very briefly, introduction to Crunch. We're not here for that, so I'll make that as brief as possible. Basically, we enable companies to make better decisions using AI, algorithms, etc. in the broad sense of the word. And we try and do that with sufficient business understanding, meaning that we always pay attention to the business case of the client. Here in this case, of course, not a business case, but we will change our capitalist ways for once, and we will try and do something good and try and increase donations. So we're still talking money, still filthy money, so we're still quite comfortable there. But we'll try and increase the donations for Kom op tegen kanker. That's the goal here. And the purpose of what we do as a company in general is also to get things into production, meaning that we don't just build proof of concepts, we don't just build models on paper, but we try and get models in practice, in deployment, in use. Timeline, I started in Ghent 2016. Right now also office in Rotterdam, and now a small satellite office since January in Antwerp, to be a bit closer to clients in the Netherlands, and actually to organize meetings between Belgium and Netherlands teams basically, and also looking a little bit across the border to Germany for the coming years. So 2020, a bit of a stagnation in team size, but 2021 should see the old trend to return there, and further increasing team members throughout the coming years, hopefully. some pictures. 3 big things we do is, on one side, roadmaps, strategy, what should you be doing, helping companies decide on that. Projects, lion's share of what we do, basically 85% of what we do is the actual project. And then additionally, also training, educating, can take the form of management traineeships, can take the form of knowledge transfers, you name it. So getting knowledge sufficient to a sufficient level to get people to adopt models that we built for them, or even extend the models that we created for them. So now, why we're here, project objective. So I would go a step further than what Tessa said. We're not just going to try and predict donations, we're going to try and increase donations. So try and make some predictions that show us some good levers to pull on and say, okay, if we do things a little bit more this way, this should increase donations in the long run. So to do that, we have already received a data set, just historical information for the past 4 years. I've taken a quick look over the weekend, and normally it looks quite okay. And I also believe that we will be able to augment that with some data and information we find online, hence the natural language processing that Tessa also already hinted at. Big chunks that I saw in this project. So like I mentioned, we're still at the start of the project. We still have a lot of figuring out to do. We still have some conversations with them coming up to see what is feasible, what is useful for them, and what may not be. But of course, big chunks already apparent. One big thing is structuring campaign information. They do a number of different events. You have people coming in because of the press attention, because of the online attention that these events generate. Can we, in the first sense, create a data set of those events using things like natural language processing to make things a bit more structured than they are right now? This organization, like many others, doesn't really have a very structured data set on the events and all the communications they do, but might be useful to create such a thing. And then, of course, trying to create links between events and donations, either exact, meaning I know that this person donated at this specific event, or fuzzy, meaning that we just infer because there is a peak in donations around a certain event that donations were influenced by it. And then also see, okay, what does that mean basically for the lifetime value of a donor? And then we enter into a domain where Crunch has a lot of experience, being retail. And in a sense, this resembles that quite a bit. Big pool of customers, so to speak, here, people donating money. All of these donations, or all of these people will have a certain lifetime value to Kom op tegen kanker. And then, of course, we will try and maximize that value and try and see how we can play into that. So that's the third part here, looking for these causal links. And of course, if we're talking maximizing donor value, you can try and predict that. And what do we use for that, or what would you use for that? Basically, historical donation behavior as well as descriptive properties. The second set, descriptive properties, right now is a bit limited. We just have gender and broad locations. So we'll have to see if we can get some more information there, maybe some information from email campaigns and so on. But one interesting thing that we would like to analyze in this donor behavior is basically people making recurring donations. And what would be the ideal amount to ask for in such a situation? If you ask for too much, people are likely to stop their online or stop their recurring donations sooner. If you ask for less, of course, you're leaving money on the table. What is the ideal balance there? And are there factors that influence that ideal balance? Say, for instance, age or income group are likely to influence that. If we can lay our hands on some or information of something of that sort, that would be interesting. Things like we have the zip area codes right now. People living in Knokkelenzuid or Latem might feel a donation of 100 euros a month a little bit less than people living in other locations, of course. So that's all things that we can try and tie together to try and increase the data set and increase the size of the information we have to base decisions on. So that's the second part. The third part also, which I think is very important moving forward for them right now, the information they sent me, typical shape, spreadsheets, CSV separated files. So suspicion, they don't really have anything of a data warehouse. They don't have data prepared for analysis. Giving them some advice, showing them how you guys will have prepared their data for them in a format that is much more useful and much more accessible for them to analyze their figures. That should also be a very relevant contribution to what they are doing with their company. And of course, associated with that, you can give some recommendations in terms of software choices, show them how they can use various database technologies, data pipelines, dashboarding software, and so on. To be divided, of course, to be decided when we talk with them, to be decided based on their experience level internally. And then the fourth thing that I just wanted to add, because the past three things are just top of mind from my end, but I also believe that just looking for best practices might also be something valuable. Undoubtedly, there are a lot of organizations similar to Kom op tegen Kanker who do a lot of different things. A lot of those are likely to be data-driven. Let's see what's out there. Let's see what we can translate, and let's see what ideas we can come up with for this organization in specific. So basically, that's it. We'll decide with the project team itself, or we'll discuss the timeline in depth and the task division and so on and so forth. The idea is that you'll be treated somewhat like a project team would be at Crunch. And you might have also seen Lieselot, who is also a member of Crunch, has just joined or has joined. I saw she was already present during the previous presentation, during which I was at the phone. Apologies for that. But she was already here, and she will be the person who's likely to be guiding you or guiding the team with the weekly sprint meeting, so to say. So basically, that's that. That's my quick introduction to what this project would be, at least from my perspective of where I am standing right now.
Perfect. We wish the whole team we wish them good luck, and hopefully they can increase the donations for Kom op tegen Kanker, so we can win the battle against cancer. Now I will give the word to Charles, Peter, and our own finder Casimir, who will present the project of Engie and Element61.
Thank you. I'll share my screen. So the third project is between Engie and Element61. It's about using open sensor data of wind turbines for predictive maintenance and output forecasting. The project responsible is Tim Willems. However, I will be giving this short presentation on behalf of Engie because they could not make it today. And also because I'm the founder of Everest together with my fellow board members, but I also founded a startup, DeltaQ, that uses leverages AI in the maritime industry. And we did a brief stint on predictive maintenance for predictive maintenance on wind turbines, just for fun and because we had the time in the beginning, but now we're fully focused on the maritime aspect. But so I have some experience on this. First, let's give some context on the industry. It's a booming industry. Onshore wind is supposed to increase by threefold by 2030 or 10x by 2050. Even more impressive are those numbers for offshore wind, which is still in a very early phase. So that's going to go 10x in 10 years and even 50x by 2050. So the industry is really booming. And a very important thing to note is that the operations and maintenance costs make up to 30% of the total costs of wind energy. So LCOE, levelized cost of energy, is all the different factors over the lifetime of a wind turbine that in total make up the price of wind energy. And the goal, of course, is to drive that energy price down as low as possible so wind energy can be even more competitive compared to other less green and renewable alternatives. And one of the recent focuses of the industry is to drive those O&M costs down, especially for offshore wind turbines, since maintenance costs are 3 times higher than for onshore turbines, obviously because it's much harder to access, much harsher operating conditions, etc. Now, how does data come into the picture? That's through predictive maintenance. So there are lots of types of maintenance. The worst one, I would say, is not even on the picture, is reactive maintenance. You wait until something breaks down and then you start and try to fix it. The other one is preventive maintenance. That's like you say, I replace this component every year, just so there's no issues. And then in a more intelligent phase, you get to predictive maintenance, and then the subsets, such as proactive maintenance, so actively monitoring what kind of values are we observing, and could they be a telltale sign of an issue that we can react to. The other one is predictive maintenance, looking towards the future. What could happen? An example could be lifetime component estimation. How long will this gearbox be able to function like it is right now without having a failure? And the last one is prescriptive maintenance. The most advanced one is what should you do? And that's really the realm of AI. And the industry believes that predictive maintenance is going to be an integral part of driving the costs of renewable energy down even further. Maybe I'm just going to give some really basic intro to wind turbines, because they're not as simple as a lot of people expect them to be. It's not just the more wind blows, the more energy it creates. It's a tad bit more difficult. So I'm going to give some really basic concepts. The first one is the cut-in speed. That's the point where the turbine starts producing energy, because below a certain speed, it's not worth it to let it turn. That's here. Then you have the rated wind speed is at the top. So at a certain wind speed, the power output is capped, as you can see, and that might be a bit odd because you think the more wind there is, the more power it will produce. But the reason it's capped is because above a certain speed, it's not safe to let the rotors turn even faster. So they control this by changing the pitch of the blade, so by rotating them slightly in an actually less efficient way. So less wind is captured, but the turbine can still continue to turn at a lower rotational speed. And then there's the cut out speed at the end, when it gets too dangerous to let the turbine turn at all, and then they just put on the brakes and the turbine stops rotating. So that's also a kind of special curve already. Then there's other factors next to the wind speed, such as the yaw. The turbine should always be facing directly towards the wind, but the wind changes and the turbine can't react that fast, and so the yaw is the error between the optimal angle it should be at, because it's lagging the optimal angle. Then pitch is what I explained a bit before, how the blades can rotate to become less efficient to allow it to operate at higher wind speeds. Wake is something interesting for the project as well, is when the wind hits the first turbine, and then behind the first turbine is a second turbine, which gets less wind, because a lot of wind is already captured by wind power is already captured by the first wind turbine. Then air density also has an influence, and the tip speed ratio is something important, because when we at the startup started this project, we actually thought it was as simple as the higher the wind is, the more power there is, and the faster the blade turns. But that's not how simple it is. The rotor speed of the blades is actually controlled by changing the demand in torque they require. So by controlling this factor, they can actually control how fast the blades rotate. And this is to optimize the tip speed ratios to capture as much energy as possible given a certain amount of wind. So to be able to model these things correctly, you have to understand these concepts. I went through them really quickly, but everybody on the project, I recommend you going through them as well, because it's more complicated than you think it to be, and it's crucial to understand this before you start any modeling. Then the project is together with Engie, a very well-known company, very big company. They do gas, nuclear, renewables, etc. all over the world. They're from France, but they're very big in Belgium as well. They also have their own team of data experts working on this topic, so on predictive maintenance for wind turbines. So they have some experience in this, and they're looking forward to think together with us and are curious to what we can find. The data we got from the Engie turbines is open data, and it's from a wind park in France. So they're not yet sure if they're going to work together with us with people from Belgium or from France, and they're still deciding on this internally. But our person of contact currently is Koen de Bouw, who has a lot of experience on this topic, and he's looking for the best person to function as the client person within Engie, but they're very curious to what we do during this semester. So without further ado, I'll stop sharing and I'll give the word to Peter and Charles from Element61, who will be guiding the project.
Yes. Which screen do I need to share? It's this one. Yeah, should be fine.
Yes,
perfect. All right, very briefly, Element61. What we do, we are a consultancy firm. We're 70 people, active in 3 big domains. It's all about data analytics in what we do. So firstly, we're active in business intelligence, let's say traditional reporting, traditional dashboarding, setting up data warehouses. Secondly, for the people who have some more interest in finance, performance management has everything to do with the finance office or the CFO office. So here we help organizations with their budgeting, planning, forecasting process, consolidation. And then lastly, data science and strategy team, where both Charlotte and I are working in, where we help organizations innovate through and with data. And I think that the innovation aspect is an important one, and of course the data aspect is an important one. So in essence, what we do is we help our customers from ID to activation. And what do we mean with this? Well, often we start off with brainstorming sessions on what data could mean for an organization and how they can innovate their business using the data that is already there or that they might not be capturing, but they could possibly start capturing. Secondly, we help organizations in defining an architecture that will enable them to put all their data analytics solutions into production, and we help them start capturing data, real-time data, unstructured data, and make sure that all their machine learning models or AI models can be put into production. Thirdly, we help them actually build those use cases. So with our data scientists, we actually help build those models. And then lastly, I think an important aspect is the change management, where we also help from a process point of view to embed those applications in the processes and help people understand what is actually happening. So why do our clients do it, and what is, let's say, the success? I think we can always put it in 4 big buckets. Firstly, it's about gaining insights, agility, also building out competitive edge, ideally start building new business opportunities. And of course, a very important one is the customer service, which can be kind of redesigned if we start analyzing data. If you look at the logos, you also see not very much related to one particular industry, nor any specific functional domain. So in a way, very open and always happy to listen to what our customers are asking for. And lastly, I just wanted to quickly share some internships that we have just posted online, where we are looking for people to join us for a summer internship or maybe also beyond. And as you can see, similarly as our different types of customers and functional domains, also our internships are quite broad. We're looking for some more data engineering skills, but also marketing skills. And the last one is then most related to what we're trying to do with Engie, is building out predictive maintenance on industrial equipment. And so if you're interested, you can click on those links and then you'll get in touch with us. And then I'll leave the floor to my colleague Charles, who will be guiding you in this project and explaining you a little bit how we want to tackle it. So Charles, the floor is yours.
Yeah. All right. You can already see my screen.
Yeah.
It's visible. All right. Perfect. So I think Casimir already introduced you to the data set of Engie as being Engie for this project, at least for this meeting. So it's an open source data set from a wind park in La Haute-Borne that consists of more than 7 years of data. I think in total, or just less, 5 years I see. But we have a data point in every 10 minutes. So that's a huge amount of data that we can use. It's not like Hydrofox for the ones that were here last semester that we just have a day of data, but this time we have a whole bunch of data. In addition, we have some weather data that we can use, which is obviously crucial for wind turbines. And it will be very interesting to combine that data. However, we're still waiting to see if we would get maintenance and log files. And maintenance files to know, if you want to predict maintenance, we also need to have data that we can train on, and that's the maintenance and log files. However, if we won't have them, we have a plan on how to tackle this, and I'll come back to that shortly. The data here, it's very structured. Engie has a lot of engineers and a lot of data specialists, as Casimir mentioned, so they do have structured data, and we have a lot of information about every aspect of the wind turbine. It's about 40 fields that we see here, and the table is split up in two of just variable names and the unit of the variables. So we have a huge amount of data available for us to work with. And there is a lot of data, so that means there are a lot of sensors in the wind turbine, but that also means that a lot can go wrong and a lot need to be maintained. So many things can break down. It's our job to find the malfunction before it happens, or to at least predict with some statistical relevance. And so we will plan the downtime of windmills, or predict the downtime of windmills. If we do not have the data, the maintenance log files or the breakdown logs of Engie, we will predict the output of the turbine. If we can predict the output and log it and benchmark it as a digital twin to what's actually coming out, if both of them have a growing difference, we could say there's some kind of anomaly, and we could see it as a sign of breaking down, or just putting a warning or a flag. So that's a little bit how we would tackle it. Obviously, you're completely free, and the group is completely free to have different ideas on how to do this, and we're happy to support that. However, what's interesting is that, as Peter mentioned, we are not doing predictive maintenance models on CSV files and then returning a CSV file that says this wind turbine will break down at that moment. No, it's something that we want to have in a platform, and that's always what we do at our customers. That's why we also focus a lot on data engineering. I think that's something that Kent University lacks a little bit in their program is data engineering. However, there are several reasons why they don't have it yet. Also because we're talking about mostly about the business engineering faculty, and that's not one of their main focuses. But we're here to help you with that. So what we propose as well is that the team that we will be working with on the Engie data is that we deliver a platform, and the platform that is running not on a computer, not based on CSV files, but automatically scheduled a pickup from the data warehouse from Engie, puts it in our data lake, notebooks that are scheduled continuously, once every night or once a week to train, and once a day to score, or once every 10 minutes to score. And then we have also a visualization in which we can monitor everything. And so we actually deliver a tool for Engie in which they can see the results. And nobody will have to run it on its PC or have its PC open 24/7 to maintain it and to have an engine. But this platform will run automatically in the cloud. It's something that I think can be a very relevant experience for all of you, at least for the people that don't have experience in it. And it will also show you if you want to have your own little project or your own startup, where you should start if you have a data platform and you want to have something up and running in the cloud without having your computer needing to heat up 24/7. I think this is this mini data platform. If you have questions about it, and it's not that complex, but I can imagine it's new, you can always just ping us. But we will see each other anyway, or the group that works with us, I think, next week. So Casimir, I'm not sure if you want to add something to it.
No, that sounds perfect. Sounds really interesting, and I fully agree on what you said, that some data engineering experience for business engineering students and even civil engineering, computer science students would be very, very interesting.
Yes, I think so indeed. All right.
I guess the word. Thank you. I think the word then goes back to Willem with some concluding remarks.
So, thank you very much. Hopefully everyone enjoyed our kickoff event. If there are any questions, you may raise your hand. Normally in Zoom, you can click on a button where you can raise your hand if you have any questions. Some more information, your project leaders and project responsibles will probably set up a group chat, or maybe some of them already have done it, and all the communication will go through there, through that. Probably will be Facebook or WhatsApp. And then as well, in the upcoming weeks, we'll have a second lecture event. So make sure to follow us on Facebook, Instagram, and our LinkedIn for sure, so you can see when our next event will be. And yes, if there's any question, please raise your hand right now. And as well, if you don't, if you have a question later, just talk to the project leaders and project responsibles, and they will help you. And if you have any questions about Everest Analytics, you can always contact me, or on our new website as well, everestanalytics.be. So all the information is there as well. Perfect. So I don't see that anyone has a question. Maybe it's been a long day for everyone. So maybe we will end the call here, and I wish all the groups I wish them good luck, and hopefully we'll see each other in real life.